For the first time in the industry, Total is testing and validating the real-time 3D reconstruction of a methane cloud for quantitative use by means of cutting-edge infrared imaging technologies. These tests are being organized by the Major Accident Prevention R&D project and the Platform for Experimental Research in LAC and form part of the action plan of one of the 8 EP strategic research programs.
The Sustainable Development Programme deals with areas of key concern for our stakeholders. For example, the prevention of major accidents or being able to face both environmental and societal challenges, or all areas related to water management. In crisis situations, certain information is essential. Firstly, it is crucial to have an estimate of the leakage rate, as knowing whether the rate is rising, stable or falling will allow us to manage the crisis from a strategic point of view. The second requirement is to know the location of the cloud in order to manage the operational aspects of the crisis.
The infrared cameras currently available on the market are capable of detecting the presence of gas, but do not provide any figures such as the level of methane concentration at a given point. The aim of the test campaign, carried out on the industrial platform for pilot units in LAC, is to determine values such as the gas leakage rate, the concentration inside the cloud, in particular at the limit of the explosive zone, and an estimate of the explosive mass. This campaign was the first to be performed on this industrial platform dedicated to R&D pilots.
This industrial pilot platform makes it possible to generate a very good complementarity between the laboratory activities and micropilots developed in Pearl, and the possibility to develop large-scale installations that will allow us to test and validate relatively mature technologies that will then be used in various ENP projects. On this platform, we can combine the know-how of the Pearl teams in operations of research applied to ENP issues with the risk management needed for a Seveso-rated industrial facility. For this measurement campaign, we have 3 hyperspectral cameras, conventional infrared cameras, and some R&D innovative prototypes located at 3 different points in order to reconstruct the 3D gas plume using a technique called tomography. We have also positioned around 50 gas detectors on stakes to measure the methane point concentration. This real-time reconstruction software is being tested for the first time. The data obtained will enable us to validate the reconstruction model. The instruments we are interested in here are those for spectral imaging, where we obtain the spectrum of varying wavelength resolution across these different spectral bands for each pixel of an image. If we then study the spectrum, the first step is to see if we can identify the specific signature of the methane absorption. Then once the signature has been identified, we can transpose it into a physical datum, i.e. the concentration.
This test campaign is a success because the real-time reconstruction worked perfectly, and the tests that were carried out with various gas flow levels showed that the estimate was within the expected order of magnitude. The R&D teams will now make full use of the extensive information obtained to compare the estimates of concentrations in space with the values measured by the stationary sensors, in order to improve the algorithms for both the reconstruction and the gas flow estimate, and thus ensure a more effective safety management.
The objective of this first test campaign is to evaluate the capacity of these tools to perform environmental monitoring on our industrial sites and to measure, for example, greenhouse gas emissions. Safety and risk management on our installations are key for Total. This test campaign is the very first experimental campaign. Looking to the future, we are planning to carry out 1 campaign a year over the next 3 years. And our ambition over time is to qualify this technology to manage our risks more effectively and above all at a reduced cost.